Hey there, Dr. Anna Maria Helt here at Osada Natural Health. Welcome to Monday's Mushroom, episode 16. I thought I would talk about mushrooms and vitamin D this week. And so let's get into it. So we all hear about vitamin D pretty frequently, right? We know it's important for calcium uptake in our intestines here, diagrammed on the left. We know that vitamin D is important for bone density because it helps bones absorb things like calcium and phosphorus. We know that vitamin D is actually important for the development of the cells that line our intestines. Vitamin D is also important for the function of many of our immune cells. And in fact, people with low levels of vitamin D are at higher risk for having an autoimmune disorder. Low levels of vitamin D are also linked to a higher level of other immune reactivities, for instance, certain forms of dermatitis and allergies. And also low levels of vitamin D are linked with an increased susceptibility to infection and to developing cancer. So vitamin D is really important. Now, vitamin D, there goes my dog, always making noise when I record. Vitamin D, in order to do anything, it actually has to be metabolized both in the liver and in the kidneys to its active form. And it's this active form that is responsible for the functions we attribute to vitamin D in the body. So what happens in a schematic kind of view here is that vitamin D, the active form of vitamin D in the body in circulation, as represented by this blue oval, goes into our cells. This might be a bone cell, this might be an immune cell, but it goes inside of the cell and binds to the vitamin D receptor, VDR, this little red crescent here, the vitamin D receptor. Once the active form of vitamin D sticks to its receptor in the cell, they are transported into the nucleus and they activate vitamin D responsive genes. And so again, these are genes involved in intestinal cell differentiation, in calcium absorption through the intestine. These are genes involved in bone growth, bone recycling and such. All these different things that vitamin D does. These are, immune cells turning on different genes. So this is kind of in a nutshell how vitamin D acts in the body. Now, coming back to mushrooms, mushrooms have something called ergosterol in them. It's a steroidal molecule, and in response to UV light, ergosterol is turned into something called ergocalciferol, otherwise known as vitamin D2. So you see some beautiful chanterelles here that are really high in both ergosterol but also in ergocalciferol, vitamin D2. So if you've ever hunted chanterelles, you'll know that they do get some level of sun exposure. They do get some level of UV exposure in their life cycle. At least they do here in Colorado. On the right here, we have something called cholecalciferol, which is vitamin D3. Like vitamin D2, this is also made in response to UV light. One source of this is in animal-based foods, things like eggs, for example, and meats, and especially fish. But we also make our own cholecalciferol, vitamin D3, from a precursor that's in our skin. And so your grandmother might have told you to get out and get some sunshine for your vitamin D, and that's a real thing because we need sunshine, we need UV light to turn the precursor that we have in our skin into vitamin D3 or cholecalciferol. So you don't have to be an omnivore or a meat eater to get vitamin D3 in the body. We can make our own. So even vegans make their own vitamin D3, but we can also, of course, bump up our D3 levels by eating foods that contain it. Now, let's see. What else do I want to say? Of course, the dog is now walking laps behind me, making noise. Hopefully that's not showing up too much. Coming back to mushrooms and vitamin D2, It does take UV light in order for mushrooms to have a significant amount of vitamin D2. So chanterelles growing out in the wild, boletes, which grow out in the wild, tend to have quite high levels of ergocalciferol or vitamin D2. Button mushrooms kind of grown in the standard way, which is in the dark, will have low levels of D2 until you expose them to UV light. So if you expose your typical garden variety, or I should say grocery store variety button mushroom to UV light, it will approach these wild mushrooms in the level of vitamin D2. So just a little tidbit there. So one other thing before I move on, when you hear about things like, you drink your milk to get vitamin D, it's because the milk has been largely augmented with synthesized vitamin D2 made from yeast, which is another fungus, or, breads and breakfast cereals, all that stuff that is vitamin D fortified is fortified with vitamin D2, not with vitamin D3. Now, in looking at these molecular structures here of ergocalciferol versus cholecalciferol, can you see the difference? Here it is if you don't feel like figuring it out. Vitamin D2 or ergocalciferol has a double bond that is not present in vitamin D3. So I have a little circle here to orient you to the parts of the structure I'm talking about. You'll see a double bond there. That is actually between two carbons, which is obvious if you're a chemist and used to looking at chemical structures, and maybe a little bit more mysterious if you're not. So you can take my words on it. You see those two little lines there in the circle. That's a double bond. Vitamin D2 also has an extra methyl group, which is indicated by that bold line on the right-hand side there in the circle. So both that double bond and that extra methyl group are absent in vitamin D3. So their structures, though, are largely similar. There are a couple of differences there between the two of them, and I'm going to come back to that in a little bit. Now, let's get to some practical questions here. How bioavailable is vitamin D2 or ergocalciferol when you eat a mushroom, say cooked chanterelles, versus when you pop a vitamin D2 supplement? And the answer from research is that they are more or less equally bioavailable. If you cook chanterelles and you know from doing some chemistry on them how much D2 is in them, and you give that to people versus a capsule with the equivalent amount of D2, people wind up with the same blood levels. So you can eat a mushroom and the bioavailability is fine. It works. You can get it from mushrooms. And so this was done in a small 3-week study comparing folks eating chanterelles that has D2 in them, just normally in them, versus folks taking D2 in a supplement form. Both raised serum levels of the active, the metabolized form of D2 in the body to a similar extent. And incidentally, you may be wondering what happens when you cook the mushrooms to the integrity of that ergocalciferol, that vitamin D2. Actually, about 85% of it or more remains even after different kinds of cooking, whether we're talking about boiling or frying the mushrooms. So cooking the mushrooms doesn't really destroy much of the D2 that they provide. Now, comparing D2 ergocalciferol to D3 cholecalciferol, how bioavailable are they when you look at the two of these forms of vitamin D? So for instance, getting a mushroom form of vitamin D, the vitamin D2 there, versus say eating eggs or sardines or some other food source of vitamin D3. The answer is that the absorption of D2 is the same as the absorption of D3 based on studies in people. So the bioavailability in terms of how well we absorb them as people, they're the same. But there are some differences here. So a study done in people that were given one massive dose of either ergocalciferol, vitamin D2, or cholecalciferol, vitamin D3, the clearance was different, meaning that the body got rid of vitamin D2 faster than it got rid of vitamin D3. So there was a significant difference after a couple of weeks in the levels of active D2 in the body versus active D3. And just to make it a little more confusing, though, this was done in a study where people got 1 megadose of either D2 or D3, which made people think like, oh no, this is a problem. D2 isn't hanging out long enough to do anything. But when studies looked at daily dosing, so not a megadose, but dosing every day of vitamin D2 versus vitamin D3, circulating levels of their active form were actually pretty similar. So the increased clearance of vitamin D2 became apparently less of an issue when people were taking it daily than when people took a big dose of either D2 or D3. So hopefully I haven't lost you yet there. And along these lines, actually, before moving on, studies also looked at this from another point of view. Another way of looking at this is in terms of daily supplementing. Supplementation of vitamin D2 daily was just as good at increasing active levels of vitamin D2 floating around the body as supplementing with vitamin D3 was at increasing levels of active D3 circulating around in the body. So again, kind of similar there. Now, another question, though, is does vitamin D2, ergocalciferol, something we would get, for instance, from mushrooms, have the same effects in the body as cholecalciferol, the vitamin D3 that we make in our skin, or the vitamin D3 that we would get from seafood or eggs, or from a pill in either case? Do they do the same thing in the body? Well, both vitamin D2, the active form, and both the active form of vitamin D2 and the active form of vitamin D3 pass inside of our cells and bind to the vitamin D receptor, which then in turn turns on vitamin D responsive genes. So they can both turn on vitamin D responsive genes in the body, which is how vitamin D does its thing. However, binding studies have found that vitamin D2, ergocalciferol, does not bind as well, or as tightly, I should say, to the vitamin D receptor as vitamin D3 does. Vitamin D3 binds more strongly to the receptor, which could suggest that vitamin D3 is indeed stronger in the body than vitamin D2 in terms of what this vitamin does. Now, something else I wanted to say about that. So this is one of the reasons that vitamin D3 is often considered to be the better option as a supplement, in part because of the differences in binding to the vitamin D receptor, and in part based on those studies that do one big dose of the two different forms and find that D2 drops faster than D3 in the body when given in one big dose rather than supplemented every day. That said, in rodent studies, when mice and rats were given ergocalciferol vitamin D2, it actually did improve, for instance, bone health in them, multiple aspects of bone health, like bone density, for instance. Now, to be clear, we're not rodents, right? We have different metabolism and such. I'm not a big fan of animal studies regardless, one, because of the ethics, and two, because we're not the same. But evidence from rodents suggests that ergocalciferol D2 is doing something in the body, perhaps. Now, there was a study in actual people. So in people, for instance, with end-stage kidney disease, where there's all sorts of electrolyte and mineral imbalances in the body that can impact bone health. In people with end-stage kidney disease, the use of ergocalciferol vitamin D2 actually did improve bone parameters and mineral parameters in these people. Now, unfortunately, most studies in people are, at least most of what I've found in trolling the literature, most of the studies simply are comparing circulating levels of active D2 and active D3 following supplementation. There aren't many studies looking at these important functional endpoints in terms of, well, gee, what happens in people with low vitamin D when you take D2 versus D3? Like this study I just cited, is their immune function better? Is their bone density better? Is their absorption of calcium better? There hasn't been a whole lot of work looking at that. So there's that. So to wrap it up, here we go. Here's D2 versus D3. Some, but not all of the studies show that, something I want to point out actually, yet one more complicating factor. Some, but not all of the studies that are looking at supplemental D2 in people found, here's something weird, that supplemental vitamin D2 increased circulating levels of active vitamin D2. I said that already, that makes sense. But some of the studies found that supplemental D2 decreased circulating levels of active vitamin D3. Got that? Supplemental D2 in some, but not all studies, decreased circulating levels of active vitamin D3. So I don't know what the hell is going on there. And that wasn't found in all studies, so we don't know if that is real or an experimental artifact. If it is real, what does it mean that getting D2 in the body can lower active D3? Does that have any functional impact on the body? Who the hell knows? We don't know right now, but it is a complicating issue to think about. Many people, both in the health and science community and other people, do functionally equate vitamin D2 and vitamin D3. So, you see fortified cereals and fortified dairy and such with D2. And some doctors saying, yeah, it's fine, they're the same, it's the same dose, blah, 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 blah. But other scientists and health people conclude that D2 is perhaps not so helpful because we do know that it is cleared faster, and we do know that it doesn't bind quite as tightly to the vitamin D receptor to activate it. But I would say that neither point of view, that they are functionally equivalent, D2 and D3, or conversely that D2 is not helpful. I don't think either of those points of view is really based in the truth, based on the data at hand, meaning that it's more of a gray area and that the story is more complicated than that. And so all of this is less of an issue in healthy folks who are getting the requisite 10 or so minutes of sun exposure on their skin daily. And none of this means you should stop eating your mushrooms. But it does mean when you're reading about mushrooms as like a wonder source of vitamin D, or that you're reading that mushrooms are useless in terms of providing vitamin D, to look at both of those conclusions. Take those with a bit of a grain of salt. Look at those critically. So if you've made it this far, as I say, good job. Sometimes I get a little technical in these talks. Thank you for listening. If you do have any questions in terms of clarifying what I'm talking about here, go ahead and plug them into the comment section. I always do like to look at those and respond. And if you have any experiences in terms of nerding out on vitamin D2 and D3 in your own body and want to share them, feel free. Anyway, again, thanks for watching and be well, y'all.